Moving on with functions a little bit. This lesson is going to have a couple of special terms with functions. We'll start with this, the idea of continuous. A continuous function is not easy to define. I can give you sort of a definition, but it's not very formal or official. The idea of continuous would take several volumes of stuff to go through. It is a very subtle, very rigorous, very formal and precise definition. And some areas of math define continuous differently than other areas of math. So rather than give you a definition, I'll give you a few examples of what it means to be continuous and not continuous. Sometimes, for our purposes, it'll be easier to see what a continuous function looks like rather than try to get a formal definition. So I will draw a graph on the far left here. There's a function. It is continuous. I know it's continuous because if I take a pencil, I can trace the entire path without lifting the pencil up. Here is another continuous function. I just trace the entire path in one smooth motion without having to pick up my stylus. Here's another continuous function. That is a sinusoidal. It is a function. It passes, all of these pass the vertical line test. I can draw their graphs in one smooth motion. Those are all continuous. Here's a function that is not continuous. I cannot trace this function unless I pick up my stylus. So I can draw this section, but then I have to physically pick it up, relocate it to one of these spots, and do the rest. There is a gap here, and we call that gap an asymptote. That's something we'll come back to later on, all about asymptotes. For now, just think of it as an invisible boundary that cannot be crossed. We can approach it, we can get really, really, really close, but in order to continue, we have to first jump over it and then pick up. Because I have to jump, it is not continuous anymore. Here's another example of not continuous. Now this is a kind of a weird looking function. This is called a piecewise function, and we'll talk more about piecewise functions in a later lesson. But notice again, there are holes, there are gaps. I can't trace the entire function without picking up my pencil or stylus and starting over. So I can go I have to jump from here to here, start over. And then this is an open circle. Notice. I can do this section, but then I have to jump, pick it up, relocate, and then start over. So these are not continuous. Now, the question is, why are these still functions? Doesn't this violate the vertical line test? Well, no. Because a vertical line going through here only hits one point. Remember, an open circle means don't count that. We're going to use it as a starting place, but we're not going to count that specific value because we're counting this value. So when x equals whatever value this is, I don't go there, I go here. When x equals this value, I don't go here, I go here. So let's say this is x equals 2. f of 2 is whatever y value this is. It is not this y value because it's open. Open circle means don't include. So that is continuous versus not continuous. Our simple definition will be, can you trace the entire graph without lifting up your pencil? If the answer is yes, it is continuous. If the answer is no, it is not continuous. Continuous is a topic that will be talked about again in calculus, and it's going to be dealt with a lot more formally than it is here. But at least you have a general idea of what it means to be continuous. Last thing that this lesson is going to deal with is what's called one-to-one. So this is not 1 minus 1. It stands for one-to-one. A one-to-one function. One-to-one functions have some importance for something we're going to do a little later. We say a function is one-to-one if every f of x is paired with exactly one x. So let me go back to our definition of function. Here's our definition of function. Every x gets exactly one f of x. Every x gets exactly one f of x. Well, now we're saying that every f of x gets exactly one x. This is not a new definition of function. This is a definition of a particular type of function. Every function is not going to be one-to-one. In fact, many more functions are not than are, typically, if we're looking at types. Very few types of functions are one-to-one. We can make them one-to-one by putting certain restrictions in place, but for the most part, very few are one-to-one. What we're saying is to be one-to-one, every y value only gets to have one x value. So what does that mean? Well, we know a function has to pass the vertical line test. Every x only gets to have one y. So now if every y only gets to have one x, one-to-one functions pass the horizontal line test also. One-to-one functions pass both. Functions only have to pass vertical. So let's make sure we're clear on that. A function in general only needs to pass the vertical line test. For a function to be considered one-to-one, it has to pass the horizontal one also. So let's take a look at some examples. Here I have a graph. Is this one-to-one? And the answer, of course, is going to be no. Because, let me get a horizontal line on the screen. Here's my horizontal line. Not very horizontal. That does not look very nice. Try that one more time. There we go. Right there I have a violation. Horizontal line test. This is not one-to-one. Now this is still a function. Let's be clear with that. It is still a function. This is still a function, but it is not one-to-one. It is continuous because I can trace this entire green path in one motion. Not one-to-one. Let's check out this one. Here's my horizontal line. Looks like it passes. So this is 1-to-1. In fact, that's our exponential function. An exponential function is 1-to-1. And it's also continuous. Third example. It's a function. Is it 1-to-1? Even though it's got this hole here, it still passes the horizontal line test. So it is 1-to-1, only now it's not continuous. Not continuous. I'm going to take my horizontal line with me for the next page. So a 1-to-1 function does not have to be continuous. And a continuous function does not have to be 1-to-1. Next page. Paste my horizontal line here. Let's check out this, a sinusoidal function. Clearly not. This is going to violate 1-to-1 many times. But it is continuous. Continuous, not 1-to-1. Next example. This looks like a cubic. It's been shifted a little bit. Looks like it's good. Continuous and 1-to-1. Last but not least, I have a rational function. Looks good. 1-to-1, not continuous because we have this asymptote. So that is 1-to-1 and continuous. 1-to-1 is a function that passes two tests. Again, if it fails horizontal, it is still a function. To be a function, you just have to pass vertical. To be 1-to-1, you have to pass both. To be continuous, we need to be able to sketch it in one smooth motion. Now, I'll preview something that's coming up a little later. Some functions have what are called inverses. And I'll give you a little spoiler here. If a function is 1-to-1, we can find its inverse. If it's not 1-to-1, then we can't find a general inverse, but we have to do some modifications in order to find it.